Hello students, my name is Shashank Shekhar. So today we will do the NCERT Exemplar problem of structure of atom. The first question says that which of the following conclusion could not be derived from the Rutherford alpha scattering experiment? Okay, so let us see. The first is most of the space in the atom is empty. So it is correct. How do we know it? Because most of the alpha particles went straight through without any deflection, means indicating that there is nothing that is present there in the space. That is the reason they are not getting any deviation. Second is the radius of the atom is about 10 to the power minus 10 meter, while that of nucleus is 10 to the power minus 15 meter. So it is also true. So by carefully studying that which are getting reflected. Okay, so if it is getting reflected, then it means that there is a radius, there is a nucleus because alpha particle are positively charged. Okay, and by determining the distance between the two nucleus with the help of sophisticated scattering, we can just determine the atomic radii also. Next thing is electron move in a circular path of fixed energy called orbits. So this thing is wrong because it does not define any orbits or something like that. It was defined by Bohr model. Okay, so this is incorrect. It cannot be derived from the Rutherford alpha experiment. Option D, electrons and the nucleus are held together by electrostatic force. Yeah, it is also true because he has defined that the nucleus is positively charged and the electron is negatively charged and the force of attraction is the electrostatic force of attraction. Okay. Next question, which of the following option does not represent ground state electronic configuration of an atom? So there are four ground states. Okay. Now, if you talk about the order of the say subshell, it is same in all of this. 1s, okay, sorry, 1s, 2s, 2p, 3s, 3p, 3d, and 4s. So this is good. Now, if you talk about the electrons, then up to 3p, it is common in all of these four options. Now, the difference lies in these two, that is 3d and 4s. Now, if you see the A option, then of course this will be filled first. Okay, 4s will be filled first due to n plus L rule, so it is completely filled, and then we will fill 3d. Okay, this is correct. What about this? In this case also we have followed the ideal condition, but it is an exception here. We cannot follow the ideal condition for this configuration because if we just put one electron of S in the D, before putting in S, if you put in the D, that would result in D10 configuration, and that is a stable configuration, right? And also, the 4s will also have a half filled configuration, which is again a stable one, right? Okay. So yeah, but we don't have any stability for half filled orbital of 4s because there is no exchange energy present there. What about C? So this one is correct. Okay, so this and this are having the same number of electrons. So of course one of these will be incorrect, and this one is incorrect, and this one is correct. What about this? So this is correct because it has 3d5. Okay, 3d5. So there is exchange energy that is present, and therefore half filled is present in both of this, and hence are more stable. So option B. Okay. Now Uh, so see, it is the same thing is written that the correct configuration is 3d10 4s1 and not 3d9 4s. And this is for copper. So copper has an atomic number of 29. So if you count this electron, so 2 to 4, 6 for 10 to 12, 12, 6, 18, 18 and 10, 28 and 1, 29. So it is for copper. Okay. Next question. The probability plots of 1s and 2s orbitals are given in the figure below. So these are the two probability plots of 1s. This is for 1s. Why I am saying it is for 1s? Because it is of smaller size, and we know that 1s is of smaller size as compared to 2s because of the because of the smaller principal quantum number. The question that is being asked here is that on the basis of the above diagram, we have to say that which statement is incorrect. The first statement is 1s and 2s orbital are spherical in shape. So this is very obvious from the diagram. Okay. Second thing, the probability of finding the electron is maximum near the nucleus. Okay. So this is also true. Okay. By why it is maximum near the nucleus? Because of the greater force of attraction. So it is not on the nucleus, it is near the nucleus. Next thing, the probability of finding the electron at a given distance is equal in all directions. So it is also correct. So although it may look like that this is not symmetrical in nature, but if you take the average density, suppose you have taken multiple pictures. Okay, so this is one picture. You have taken multiple pictures. So the average diagram that you will see. Okay, so if you put all this diagram on one of top of other, then the average diagram that would appear will have the symmetrical density. Okay, will have the symmetrical density around each direction. So if you move from the center to left, you will get the same electron density. If you move from center to right, you will get the same electron density. So this is also correct. Fourth one, the probability density of electron of 2s orbital decreases uniformly as distance from the nucleus increases. So this is not true. Okay, so it happens in this way. First of all, it increases as we move away from the nucleus for shorter time. Then again it decreases. So for at which instant it will decrease, so whether it will decrease early or it will decrease later on, that will depend upon the principal quantum number. But there is not such a relation that it will decrease. It will first increase and then it will decrease. So D is the incorrect option. Okay, the same thing is mentioned here also. The probability density of electron in 2s orbital first increases and then decreases. After that, it begins to increase again. The distance increase from the nucleus. So as the distance goes on increasing, first it increases and then it decreases. Fourth question: which of the following statement is not correct about the characteristics of cathode ray? So first option says that they start from cathode and move towards the anode. So this is correct because they are negatively charged. Okay. So anode is positively charged, so it will move towards the anode. So it is correct. They travel in a straight line in the absence of an external electric or magnetic field. This is also correct. They always travel in a straight line, but in the presence of electric or magnetic field, they do deviate. Next thing, it does not depend upon the material of electrode in cathode ray. Okay, so it is also correct. So electrode is not responsible for that. The thing that is responsible is the current. Okay, so it is independent of the nature of electrode. Fourth option is incorrect because it is saying that it is dependent on the nature of gas. So this is incorrect because electron is something which is basic in nature. So each electron will have a mass of a certain amount, that is 9.1 into 10 to the power minus 31 kg, and it will not change. And it will have a charge of 1.6 into 10 to the power minus 19, and that is also absolute, right? No, I would not say absolute. That is also fixed. So there are terms after 1.696. There are some point numbers after decimal also. There are approximations also. So I'm not say it absolute. So there are the value is fixed. So this value is fixed for each and every electron. Therefore, since mass and charge both are fixed, and also the mass and charge are fixed, and the nature is also fixed. The nature of charge is also fixed. Therefore, they are all identical in nature and will not depend upon the nature of gas. So that thing is mentioned same, that the cathode rays consist of what? Of negatively charged material, particle called electron, and it was discovered by William Crookes. The characteristics of the cathode ray does not depend upon the nature of material. Okay. Fifth question: which of the following statement about the electron is incorrect? It is negatively charged particle. Yeah, right. The mass of electron is equals to the mass of neutron. So this is very wrong. Okay, one mass of electron is never equal to the mass of neutron. Third option: it is a basic constituent of all the elements. Yeah, it is also correct. It is a constituent of cathode rays. So we have already discussed it. It is a constituent of cathode rays. So B is the incorrect option. Okay, because the mass, as I've already mentioned, it is 9.1 to 10 to the power minus 31, and the mass of electron and the charge of electron. So this is with charge. Okay, so question is asked the mass of neutron. Yeah, so the mass of neutron is 1.67 into 10 to the power minus 27. Okay, so they both are different. Next thing, which of the following properties of atom could be explained by Thomson model of atom? So it was Thomson pudding model, if you remember. So first of all, it clearly explains the overall neutrality because it said that whatever may the amount of negative charge that is dipped, or that is plugged, not plugged, which is planted in the bed of the positive charge, is having equal charge. Okay, is having equal charge but of the opposite nature. One is positive, then other is negative. Second thing, spectra of hydrogen. So it is not explained by, say, Thomson model. He did not consider the stationary states also. Okay, he does not consider revolution of electrons also. Position of electron was also incorrect because he said that electrons can be present anywhere in that bed of positive charge, but it was having a fixed place. So not a fixed place, I would say. It was away from the nucleus at least. Okay. Stability of atom. Okay, stability of atom can also be not be explained, right? So because as the positive and negative charge are close to each other, they will of course dissipate energy and at last it will collapse. So overall neutrality is something which was explained by the Thomson model. Okay, that thing is mentioned here also. Next is two atoms are said to be isobars if, so what are isobars? Which have the same mass number but different atomic number are called as isobar. So first is the first option, same atomic number but different mass number. So this is incorrect. Same number of electrons but different number of neutrons. This is also incorrect because same number of electrons means same number of protons also. So that is the that means that atomic number is same. Okay, so this is incorrect. Next is there's the same number of neutrons but different number of electrons. So this is incorrect. This is correct. Okay, this is correct because the electrons will be same, will be different means protons will be different, but neutrons is, so I think this can also be a different case. Okay, because mass number will change. Yeah, this is also incorrect. Sum of the protons and neutrons is same. So this is correct. Okay, because if neutrons is same but protons are different, so mass number will be of course different. So sum of protons and neutrons will be same, but the number of proton is different. So D is the correct option. Eighth question, the number of radial nodes. So what is the formula for the number of radial nodes? Say, what is the formula for it? So it is n minus L minus 1. So this is a very important concept. Questions are asked from here. So you should remember the formula, which is n minus L minus 1. What is the value of n here? Say, so this is 3. So n, the value of n will be equal to the shell number. So n is equals to 3. What is the value of L here? So it is p p subshell. Okay, so p subshell means L is equals to 0, S subshell, L is equals to 1, p subshell. So L value is 1. Now n minus L minus 1, so 3 minus 1 minus 1. That would give you 1 radial node. Okay, so the number of radial node is 1. So here it is also calculated. So the formula that I have used is n minus L minus 1. So this is the formula for the radial nodes. Okay, so how you find it? So if you think of it, then you can derive it also. So you know that the number of nodes, the number of total nodes is always n minus 1. So this is the formula that we have for total nodes. And the number of radial nodes is equals to L. So whatever be the value of L will be the value of radial nodes. So what is the left number of, and we know that radial nodes plus angular nodes is equal to total number of nodes. So if we know the number of radial nodes and the number of total nodes, so if you subtract total nodes from radial nodes, you will get, for radial nodes, sorry, angular nodes, you will get the radial node. So n minus L minus 1. Clear? Okay. So I made a mistake here. I will not say radial node. So angular node value is equals to L. Okay. So this gives you the value of 1 as the number of radial node for 3p. Okay. Next question. Next question says that the number of angular nodes for 4D orbital. So I have already mentioned it. Whatever will be the value of L will be the value of angular nodes. So here the value of L is for D orbital is, for D subshell is L is equals to 2. You know it very well because for a P orbital it's 1 and after P we have D, so it is 2. So therefore 2 will be your correct option. Okay, what will be your correct option? 2 will be your correct option. So it is mentioned here also that the number of angular nodes is equals to L, which is the value that is assigned to this D subshell. Now for fourth orbital or for any orbital, now this is true for any orbital. We are not even dependent upon the say orbital number for the angular nodes. It is totally dependent upon the orbital that we are talking about or the subshell that we are defining, right? So for that reason, we will have the same number of angular nodes for any d orbital. So it will be always equals to 2. Correct? It will be always equals to 2. So the number of angular nodes is 2. So is this clear? Okay. So we have calculated the formula of radial nodes here, n minus L minus 1. We have calculated the formula of angular nodes L. So n minus L minus 1 plus L, that will give you again n minus 1. So I've just memorized you that how can we just get to this conclusion. So we can say that, so if you just think of a fact, then you can say that the first shell has no nodes. Okay, neither it has angular nodes because the value of L is 0. There is only s orbital that is present. or S subshell that is present, so the value of L is 0, so number of angular nodes is 0. And since N is equals to 1 and L is equals to 0, so radial nodes will be 1 minus 0 minus 1. So again, the radial nodes are also 0. Therefore, the total number of nodes will be 0. Clear? Okay. Now, next question. Next question says that which of the following is responsible to rule out the existence of definite path or trajectory of electrons? So, Bohr has predicted that electron revolved around the nucleus in a fixed orbit on a stationary orbit. But when quantum mechanics came into picture, his idea was disrupted, and this was the main reason Bohr's model was took down. Okay. So of course, Pauli's exclusion principle is not the one. Wundt's rule of maximum multiplicity is not the one. So they are all the rule of foiling the electrons, and they still exist, and also the Bohr principle. But if you talk about the Heisenberg uncertainty principle, it uncertains the position and momentum calculation simultaneously at the same time. So the idea of trajectory is destroyed. How? Because it says that we cannot know the position and momentum both at the same time. If you know the position, momentum will be uncertain. If you know the momentum, position will be uncertain by some uncertainty, and that product is equals to h by 2 pi, h cut by 2 pi. Okay. So that thing, same thing is written that the multiple of, so this delta x represent the x that has been measured and x that is actual. So therefore, that is delta x gives you the uncertainty in momentum, sorry, position. Whereas delta p gives you the uncertainty in position, and their product is always greater than or equal to h by 4 pi. Clear? Okay, so exact position momentum since cannot be defined, hence the idea of perfect trajectory is ruled out. Clear? Okay. Now moving on to next question. Next question says that what is the total number of orbitals that are associated with the third shell? Okay, number of orbitals, total number of orbitals. So if you remember in the 10th class, then you must remember that the formula for total number of electrons is 2n square. That is a simple formula you should remember. It's 2n square. So what will be the number of electrons in third shell? So 2 into 3 square. So that will give you 18. Correct? Okay. Now since you know the number of electrons and you also know, so since it is asking about the maximum number of electrons, so also know that one orbital contains 2 electrons. So for each 2 electron you will have one orbital. So if you divide the electron number by 2, that will give you your number of orbitals. So this is simple to just analyze, right? So third shell, so for third shell the number of say orbitals will be simply n square, because 2n square by 2 will give you n square, so that is 9. So 9 is your correct option. Okay, so it is mentioned here also that the total number of orbitals that are associated with the nth shell is n square, and that will give you the total number of orbital as 9. Clear? Okay. So this formula is important. Okay, it is important. Okay, now next question says that what we have to do? What we have to do is to relate orbital angular momentum to one of the quantum numbers. So it depends upon what? The orbital angular momentum depends upon what? So for that, you must know the formula of orbital angular momentum, right? So it is h by 2 pi, okay, or h cut times the root under L into L plus 1, okay, cut times the root into L into L plus 1. So h cut here stands for h by 2 pi, right? So it is h by 2 times root under L into L plus 1. So this is the only formula that we have to calculate, that we use to calculate the orbital angular momentum, and it has no terms of either n, that is principal quantum number, or spin quantum number, or your magnetic quantum number. So we have no relation to that. So that we can from that we can say that our orbital angular momentum is only dependent upon the value of L. Clear? Okay. Okay. Now next. So it is written here also, some examples are given that when L is equals to 0, the subshell is S and the orbital orbital is spherical in shape. So this is just given the shape, because if we know the shape, we can kind of go with the orbital momentum, because your electron is revolving around the nucleus. Okay, if its path is defined in some way with the help of any quantum number, then this angular momentum is of course dependent upon the direction by which the electron is transversing. So if you know the shape, you can of course decide the orbital angular momentum. Clear? Okay. Now, next question. So here it says that chlorine exists in two isotopic form, that is 37 and 35. But its atomic mass is 35.5. This indicates the ratio of chlorine 37 and 35 is approximately how much? So for that, you should know the formula. Okay. The formula says that the atomic number of the chlorine multiplied by the ratio in which it is present, or the ratio of the relative abundance, plus 37, the relative multiplied by the ratio of the relative abundance of that particular 37 chlorine, divided by the addition of the ratios. Okay, so if you take that formula and if you plug it for each of them, you will find that this ratio comes out to be 1:3. Okay, this comes out to be 1:3, or you can do it in this way. Just take the ratio as x. Okay, so that will give you the population of Cl37 as what? It will give you as x. Okay, this will give you as x, and for Cl35 it will be 3x. So 37 into x plus 35 into 3x divided by 3x plus x. Okay, so that should be equals to 35.5. Now x is cancelled out in each of this. That will give you this thing finally. 35 into 3, 37 into 1 by 3x plus 1x, 4x. So 4. So if you just calculate this, you will find it to be 35.5. Clear? Okay. Now the pair of ions, what we have to calculate? We have to calculate the pair of ions that have the same electronic configuration. So I am leaving this question to you. I am just telling you the correct option. So it is B. Just calculate it for each of this, and you will find your whichever one of this is the isoelectronic species. Got it? Okay. Next question. For the electrons of oxygen atom, which of the statement is correct? First question. First statement, Z effective for an electron is a 2s orbital is the same as Z effective for an electron in the 2p orbital. So it is completely wrong. You know it very well. We have N plus L rule for deciding the energy. So since the energy of the orbital is not same, so the electron residing in it will have, of course, different energy. And if it is having different energy, then it is due to the reason that it is experiencing different Z effective. Option A is incorrect. What about option B? Option B says that an electron in the 2s orbital has the same energy as an electron in the 2p orbital. So this is also incorrect, because if Z effective is different, that means energy that is being experienced by the electron is also different. Third option, Z effective for an electron in 1s orbital is same as Z effective for an electron in the 2s orbital. Now you have changed the principal quantum number only, and we know on changing the principal quantum number, we change the energy. So this is also incorrect. Okay, this is also incorrect. Fourth option, the two electrons present in the 2s orbital have spin quantum number ms, but of opposite sign. Okay, so this is correct. So if you talk about an orbital, say 2s orbital, so if in 2s orbital electrons are present, so both of the electrons will have opposite spin, because for two electrons, all four quantum number can never be same. This is our simple Pauli's exclusion principle, which says that for two electrons, all four quantum numbers can never be same, and therefore the spin quantum number is different for both of the electrons. Okay, so the same thing is mentioned here, that for the two electron, the 2s orbital will have the two values of ms. First is plus half and second is minus half. Okay, next question. So in the next question, we have to see that if they are traveling at the same state, okay, then which will have a shorter wavelength. So this is a very, very good question to consider. Okay, you have to apply the de Broglie principle here. Of course, if you are dealing with the chapter, then it may seem easier at a time because you are known about each and every concept. But when it is asked in exam, you may get confused because you have studied a lot of things, and to apply the de Broglie principle at that point, it becomes difficult for some students, right? So you should be aware about all of the structure of atom concept. And this is a very important concept. De Broglie is a very important concept, including the Heisenberg uncertainty principle. This is a very important concept. So if you are traveling at the same speed, if all of these are traveling at the same speed, which of these will have the shortest wavelength? So we know that lambda is equals to h by mv. So it is according to de Broglie equation. It is very obvious. Now h is constant. Okay, velocity is now provided that velocity is constant. The only variable that is left to be considered is mass. So lambda is inversely proportional to mass. Okay. Now the one which is having a smaller mass will have the greatest wavelength because they both are inversely proportional. So which one is having a smaller mass? So we have to consider which will have the shortest wavelength. So which will have the shortest wavelength? Which will have the greatest mass? Electron, alpha particle, neutron, and proton. So of course alpha particle is a larger one. So it has neutrons plus protons inside it. Okay, two neutrons and two protons. Okay, but for electron it is not. One electron, two neutron and two proton, right? But in case of this, what we have only electrons. Of course, electron will be less than this, right? So alpha particle will have the shortest wavelength. Clear? Next question. We have the multiple choice question. So multiple choice question means more than one options can be correct. So first question is identify the pair which are not isotopes. Isotopes which having the same atomic number but different mass number. So and you should know the representation also. If you don't know that, you can consider from here also that the upper one is having a larger value and atomic mass is always greater than the atomic number. So upper one would be atomic mass only. In case there is a confusion, you should remember that the upper one is always the atomic mass and the lower one is also always the atomic number. So considering these two, the upper one is having the same. This both are having the same atomic number but different mass number. So they are isotopes. Okay, clear? What about this? So in this also, they're having the same atomic number but different mass number. So they both are also isotopes. These are not isotopes. Okay, these are not isotopes because one is having an atomic number of 6, another is having an atomic number of 7. So atomic number is varying, so therefore they are not isotopes. And it is a multiple select question, so more than one options can be correct. So you should consider the fourth option also. So in the fourth option, the atomic number is of one is 4, another is 5. So these are isobars and not isotopes. So both of these are isobars. See why? Because their atomic mass is same, 14 14 8 8, but their atomic number is different, 6 7 and 4 5. So these two are isobars and these two pairs are isotopes, isotopic pair. Clear? So C and D is the correct option. Got it? Which are the correct option? C and D are the correct option. So the same thing is written. So first, if you want to think of this question, how you would think it? So what should know the definition? The isotopes are one which have the same atomic number but different mass number, right? Which have the same atomic number but different mass number. So we have considered this concept only. And this is an additional content that, okay, if they're not isotopes, what are they? So there is possibility that these two elements can be different. They can't have any relation. But since it is very obvious, as we know the definition of isobar, so it is very obvious that these two pairs are isobaric pair. Clear? So it is mentioned here also that they have the same atomic number and different mass number for both of these pairs. So they're isobars, whereas this one has the same atomic number but different mass number, so they're isotopes. Clear? Okay. Now, next question. Next question says that out of the following, okay, out of the following pairs of electrons, identify the electrons present in degenerate orbitals. So what is degenerate orbital first of all? The degenerate orbitals which have the same energy, okay, which have the same energy are called as degenerate orbital. So first pair is n is equals to 3, L is equals to 2, okay. ml is equals to -2, ml is equals to -1, ms is same. Means orbital shell is same, subshell is same, orbital is different, right? In this case, it is -2. In this case, it is -1. So, of course, they are the degenerate. So are this, in this case, are this the degenerate orbitals? Say, out of the following pair of electrons, identify the pair of electrons present in degenerate orbitals. So, yes, n value is same, l value is same, so they are degenerate orbitals. What about this second one? Here the value of n is same, but the value of l is different. So there are, of course, orbitals which are having different energy. So we have degenerate, again I am saying it, that degenerate means different energy. So since n and l are different for the n is value same, but l value is different, therefore the orbitals will not have the same energy. What about C? So n value is only different. So of course this will have the different energy. Okay, this will have the different energy value. Clear? What about D? So in D option, n value is same, l value is same. Okay, ml value is also same, ms value is different. So of course A and D are the correct option. So you don't have to look upon the ml value. Okay, so don't get confused here. That they have done it intentionally. They have taken one example in which ml value is same, but ms value is different. So the student may get confused that we have to keep the ml value also same, but it is not true. ml value can be different, ms can be different, but n and l value, that is the principal quantum number, the Engel quantum number should be same, but orbital quantum number and spin quantum number should be can be different. Okay, so they have written the orbital related to it. You can write, if you want, you can see them. So for A, it is 3dxy and 3dyz, and for D, it is 3dx square minus y square, and it is also 3dx square minus y square, because ms value is same, so the ml value is same, therefore they are the serum orbital. This is 3px, 3dy, 3dxy. This is 4s, and this is 3d. Next, which of the following set of quantum numbers are correct? Okay, so let us see. The first is 1, 1 plus 2. So value of n is 1. That means we are dealing with the first subshell. Okay, we are dealing with the first subshell. First subshell has only L value is equals to 0, which is S orbital is the only possible thing. Right? S orbital is the only possible thing. What about the value of M? So if L is incorrect here, because L can only have the value of 0. Only S orbital can be present here. So A option is incorrect. So we'll not move further. What about the option B? So in the option B, we have N value as 2. Okay, means L value can be 0 and 1. Okay, so 1 is possible. Now for L value of 1, we can have from plus half, plus 1 to minus 1. So this is correct. So B is correct. What about C? So C is having the shell number as 3. So for 3, we have this 2. Okay, this is correct, because L minus 0, sorry, 0 to L minus 1 values are possible. So L minus 1, 3 minus 1, 2. So 2 is present. So if either it is 0, 1, 2. So if L value is 0, 1, 2, all three are possible. MS value, so MS value, ML value go from minus 2 to plus 2, because the value of L is 2. Or you can say minus L to plus L. So this is also possible. What about this? So this has a value of N as 3. And value of L will be from where to where? 0 to L minus 1. Means 0, 1 and 2. These three L values are possible. But here 4 is given. So it is incorrect. So we will not move further. So A and D are correct. So we are asked about the correct option. So B and C are the correct option. Got it? Okay. Next question. So here see, same thing is written. A is incorrect. Why? Because we have L value which is not allowed. B is correct. Okay. C is incorrect because L value of 4 is not allowed. Okay. Now moving on to the next question. Next question, in which of the following pair the ions are isoelectronic? Again, I am leaving this question to you. So this is Al3 plus. Okay, this is Al3 plus and not Ap3 plus. Just try it by yourself. It is easy question. So I am doing the first one for you. You have to just to count the number of electrons. So sodium is having 11 electrons in total. Okay. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. So 11 electrons are there. So from which one electron has been removed, that will result in 10 electrons. So it is having 10 electrons. What about Mg2 plus? Mg has an atomic number of 12. So if you remove 2 electrons, since it has 2 positive charge, that would result in how much? That would result in 10 electrons. So this both are what? This both are isoelectronic in nature. Okay, this both are isoelectronic in nature. So this is isoelectronic. So you can similarly do it for all these three. I'm leaving you as a homework for you. Leaving this one as a homework for you. Next is, which of the following statements concerning the quantum number are correct? Okay, so we have to see that which of the following statement concerning the quantum number are correct. The first is, angular quantum number determines the three-dimensional shape of the orbital. So this is very true. So it gives the shape of the orbital, that whether it will be L is equals to 0, so it will be S orbital, L is equals to 1, so P orbital, L is equals to 2, D orbital. So we have varied orbitals, and if you know the orbitals, then you get to know that whether it is dumbbell shape or whether it is double dumbbell shape, right? Or whether it is spherical in nature. So we get to know everything. Second, the principal quantum number determines the orientation and energy of the orbital. Yeah, this is correct that it determines the energy of the orbital. But orientation is something in which we have to think over. So orientation basically is what? So if you think about the PZ, so that PZ is coming from where? It is coming from the MS value, sorry, magnetic quantum number value. If you don't know the magnetic quantum number value, you cannot predict that whether it is PX or PY or PZ. And if you cannot predict that it is whether PX, PY, PZ, that means you cannot predict in which direction it is oriented. So ML value is, that is the magnetic quantum number, is important to determine the orientation or energy of the orbital. Got it? Okay. So this is incorrect. The first is correct, second is incorrect. What about the third one? The magnetic quantum number determines the size of the orbital. Is it correct? No. Magnetic quantum number only determines the orientation. It only determines the orientation. And what about the size? So it is totally dependent upon the principal quantum number, because I have said that it determines the energy. So basically, its energy is changing because its size is changing. Shape is not changing. Shape is same. Okay, it is a spherical in nature. 3s will be spherical in nature. 2s will be spherical in nature. But what is the size of the sphere? That is dependent upon the principal quantum number. So magnetic quantum number have no accountancy for that. So C is also incorrect. What about option D? Option D says that spin quantum number of an electron, spin quantum number of an electron determines the orientation. It determines the orientation and the spin of electron relative to the chosen axis. So it is correct. It determines the orientation. So it is not talking about the orientation of the orbital. It is talking about the orientation of the electron. Clear? Okay. So A and D are the correct option. So it is same thing is mentioned here, that L is responsible for the shape. Principal quantum number determines the size only. Magnetic quantum number determines the orientation of the electron cloud, not the orientation of the electron, orientation of the electron cloud in a subshell. And D, or the orientation of the orbital, I would say. And the D option says that it determines that in which axis it will rotate, what will be its orientation. Clear? Okay. So this is a very good question to summarize all of the concept that is lying behind the quantum number. Clear? Okay. Moving on to the next question. Arrange S and P and D orbitals. So these are short answer type question. Okay, you have to give the short answer. Arrange S, P and D subshell of a cell in an increasing order of effective nuclear charge. So this is a very subtle question and a very good one. Okay. So how does the energy varies in case of S, P and D orbital? So for that, you have to look upon the shape, right? So the one which is experiencing the greatest force of attraction, because since the total setup of this orbital and all are totally based upon the electrostatic interaction. Till now, that is the general perspective that will carry out. There are multiple number of forces, unknown forces that are being in the atom and that are very fantasizing to know. But for now, we will only consider the electrostatic force of attraction. Now, coming to, if you just place a charge in a sphere, to change a positive charge in a sphere of negative charge. So if I'm talking about the s orbital here, so each of, so now consider that a certain amount of charge is distributed all around the sphere. So each orbital, each electron or each charge amount will experience a certain correct amount of nuclear charge. So each will experience the same amount of energy. Whereas in case of p orbital, which is dumbbell in shape, the case varies. There is kind of I would not say it is not that much diffused, but it is still diffused, right? So it will not experience a uniform charge, and hence the Z effective will decrease. And for D, it decreases even more. Okay, clear? So same thing is written. S will have the maximum Z effective, then we'll have the P, and then we'll have the D. Next question. Show the distribution of electron in oxygen atom. So we have to show the distribution of electron in oxygen atom using orbital diagram. So that orbital diagram, so of boxes you have to show. So it is having atomic number of 8. So it is very simple. We know that oxygen has an atomic number of 8 and is also given. So we have to fill it. So there are 8 electrons. So this is 1s, this is 2s and 2p. If you calculate the n plus l value, so n plus l value for 1s is how much? 1. For 2s it is 2. For 2p it is 3. So this is correct order. Okay, so 1s, 2s, 2p. So we will fill it accordingly. Now first energy is maintained. So according to Bob principle, we will fill the one with the lowest energy. We will fill this one. So we will not move to the other one until it is completely filled. So first we will put one electron and then pair it up. Moving on to second, we follow the same thing. Place one electron, then pair it up. Moving on to the p subshell, we do what do we do? First, according to the Hund's rule of maximum multiplicity, we will put one electron in 3 and then we will start pairing it with the fourth electron. But since it is limited to it, we are able to pair the one electron only. Now why are we taking the spin opposite? So as to maintain the Pauli's exclusion principle. So every principle of this filling of electron is being explained here. Okay. Next question. Nickel atom can lose 2 electron to form Ni2+. Okay, we know that. The atomic number of nickel is 28, from which orbital will nickel lose 2 electrons. From which orbital will nickel lose 2 electrons? So first we have to write the electronic configuration. So it is 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. Now the confusion that arises here is that since we have filled the 3d electron at last, okay, so we know that n plus l value of 3d is how much? So 3 plus 2 it is 5, and this is 4 plus 0 it is 4. Okay, so 3d is having a greater value of n plus l. So we know that, right? But the question here is that it is not the way that the electron is filled, it is the orbital that is more exposed, and the 4s orbital is more outward, right? Because it is, I will not say their penetration power is less, but it is having a greater value of n. So the electron will be pulled out from there. Okay. So that will result in 2 loss of electron from the s orbital. So therefore it will be 4s0. Clear? Okay. Next question. Which of the following orbitals are degenerate? Okay, which of the following orbitals are degenerate? So you have to see that which of them are degenerate. So one we have which have the same value of n and l will be found to be degenerate. So what is the value of n here? 3. What is the value of l here? 2. So 3 and 2. Here 4 and 2. So these two are not degenerate. Here also 3 and 2. So these two are degenerate. 3 and 2. These 3 are degenerate. 4 and 2. So this and this are degenerate, and 4 and 2, this and this are degenerate. Means all 3D are degenerate and 4D are all degenerate, right? Clear? Okay. Calculate the total number of, what have to calculate? We have to calculate the total number of angular nodes and radial nodes that are present in 3p orbital. So what is the formula for angular nodes? So whatever will be the value of L will be the value of angular node. So the value of L for p orbital is what? It is 1. So the value of angular nodes is 1. What about the value of radial node? So its formula is n minus L minus 1. So 3 minus, so 3, n value is 3 here. So 3 minus 1 minus 1. That will give you a value of 1. So radial node is 1. So angular node is 1 and radial node is also 1. Clear? Okay. Next question. The arrangement of orbital on the basis of energy is based upon their n plus L rule. We know that. Lower the value of n, lower with the value of energy. For orbital having the same value of n plus L, the orbital with lower value of n will have the lower energy. We know that. Based upon the following information, so this is the information that is given, we have to arrange the following in the increasing order of energy. 1s, 2s, 3s, 3p. So n plus L value for this 1. Here 2. Here 3. Here it is what? It is 2p. So 2 plus 1, 3. Now 1 with the lower value of L will be placed for first. So 2p will come here. So 1s, 2s, 2p, 3s. Okay. Clear? Next is 4s, 3s, 3p, 3d. So n plus L value for 4s is how much? So it is 4. This is 3. This is also 4. And this is 5. So this is having a lowest value of n plus L. So it will be placed first. This and this 4s and 3p are having the same value of n plus L. But 3p is having a lower value of n. So it will be placed second. Third will be 4s. And fifth will be 4d. Okay. 3s, 3p, 4s, 4d. Similarly, we will solve it for D. Based on the above information, solve the following question. Which of the following have the lowest energy? So out of this, so this is the, I have just ordered it, but you can do it. Okay, so you have to arrange the order only. So we have done it in the first way only. So which of the following will have the lowest energy? Say, out of these four, which of the following will have the lowest energy? Of course, your, which one? So this 4D. So 4 plus 2, 5. 5 plus 4 plus 2, 6. This is 4 plus 3, 7. This is 5 plus 0, 5. And 5 plus 1, 6. So 5. So this is having the lowest value of n plus L. So 5s will have the lowest energy. What about this, which will have the highest energy? First of all, we will consider the one with the greatest value of n plus L. So 5 plus 1, 6. 5 plus 2, 7. 5 plus 3, 8. So it is having now the greatest value of all of these three. What about this? It is 6 and it is 7. Therefore, 5f is the correct option. See, the same thing is written. Okay, so this is the order that we are talking about, and this is the n plus L value. So 5s has the lowest energy, and then 5f has the highest energy. Clear? Okay. Next question: which of the following will not show deflection from the path on passing through the electric field? So the one which is having no charge on it will show no deflection. Okay. So proton, cathode rays, electron, neutron. Proton is charged plus carrying a positive charge. Cathode are electrons, so they have a negative charge. Electrons are having negative charge. Neutrons are neutral. So neutron is the correct option. Because electric field, see, we have seen that if you have placed two charge particles in place of say in relation with each other on in same field, then they will of course experience the force of attraction, electrostatic force of attraction. That can be positive or negative, or means that can be attraction or repulsion, but they will face it. But since neutron is neutrally charged, so it will not face any such attractions or repulsions. What about the next question? An atom having atomic mass number of 13 has 7 neutrons. So mass number is 7 and it has 7 neutrons. What is the atomic number of proton? So what is the mass number? Number of neutron plus number of proton. Number of neutron we know. So 13 minus 7 gives you the number of proton. And the number of proton is what? Your atomic number. 13 minus 7, it is 6. So 6 is the correct option. Next question. Arrange the wavelength in the radiation that are given below. Arrange this radiation in the increasing order of energy. So we know that the one which a greater value of lambda will have a lowest energy. So this is 300 nanometer. This is 300 micrometer angstrom. This is nanometer angstrom. So micrometer is greater than nanometer. So this is greater. Nanometer is greater. Now this nanometer is even smaller because it's 3 nanometer, and this is angstrom. So this is angstrom. Sorry for the misprint. So 30 angstrom is even smaller than this. But if you have to arrange, then this and this will have the same value because it is 30. It is increased by 1, but it is also decreased by 1 at the same time. So first, this will have the lowest value, then this one, then this one, and then this one. Okay. See, same thing written. It's written to the power minus 9 only. It is written minus 9, minus 6, and this is also minus 9. Okay. But when you will multiply it by 2 0, it will be minus 7, and this will be minus 4. So minus 7, minus 4. Okay. So this is the energy order. So whatever is the order of lambda, opposite will be the order of energy. Next question. The electronic configuration of valence shell is of Cu is 3d10 and 4s1 and not 3d9 and 4s2. What is the reason for this? Because 3d10 would result in fulfilled orbital, right? Fulfilled orbital, and that will have extra exchange energy due to symmetrical distribution of electron. So that is the reason it will be more stable. Or I would say that due to the symmetrical distribution, it has an extra exchange energy, right? So this one will be more appropriate. Next question. The Balmer series of hydrogen spectrum correspond to N1 to any N1 is equals to 2, N2 is equals to 3 for anything. This series lies in the visible region. Calculate the wave number of the associated wavelength with n is equals to 4. So for that we know the formula. Wave number is equals to 109766. Since it is given terms of wave number, so use this thing only. 1 minus n1 square, 1 minus n2 square. So 1 minus 2 square minus 1 by 4 square. So that will put this all these things together. That will give you 20564.44 centimeter inverse. Why centimeter inverse? Because lambda is nothing but 1 by wavelength, and wavelength has a unit of length. Next is, according to de Broglie, matter should exhibit dual behavior. So it can be wave or it can be particle. That is both particle and wave nature. However, a cricket ball of mass 100 gram does not move like a wave. Okay, we know that. Why it is so? So for that, for traveling in 100 kilometer per hour speed, it is not the speed that is being observed. Okay, means no wave nature is observed. What is the reason for that? So let us calculate the lambda associated with it. Okay, so wavelength is velocity is first converted into meter per second from kilometer per hour to meter per second, and then we have used this formula to calculate the lambda, which gives us as 238.5 into 10 to the power minus 36 meter. Okay, now this wavelength is very very small. Okay, so the deviation from the mean path is very less. Lambda is what? Wavelength, and wavelength is simply what? It is the displacement. Okay, not the displacement. It is the complete cycle that an electron goes when it completes one cycle. Okay, it is a distance that it is covered by a particle when it completes one cycle, right? So that is very very small. So the wave nature is not obvious from the visible eyes. Next question. What is the experimental evidence in support of the idea that electronic energy of atoms are quantized? So the most obvious reason is the line spectrum. So we get a discrete spectrum rather than the continuous spectrum. Means in between those line spectrum, there are some energies which are not emitted, which means that those energies are not possible. It means they are quantized. Next question. Out of the electron and proton, which one will give a higher energy to produce matter wave of the same wavelength? Okay, so which will have the same wavelength? So, the question is, so if the wavelength is same, which will have the higher wavelength? So we know that lambda is equals to h by mv. Okay, so lambda is inversely proportional to velocity because mass is fixed. So one with the one with the greater wavelength. So what we have to predict out of the one which will have the higher velocity. So the one with having the higher mass will have the what? Will have the higher velocity. Clear? When we multiply this wavelength here, and this velocity here, they both have inverse relation, right? So the one with the smaller mass will have the highest velocity. So electron has the smallest mass, so it will have the highest velocity. So a hypothetical electromagnetic wave is shown in figure. Find out the wavelength of the radiation. So this is given what? This is given half cycle wave. Okay. So when we call it a complete cycle, when we move from here and move to the same phase, when phase become equal, this and this have the same phase. So if this is 2.16 from here to again middle, it is 2.16 from here to again here 2.16, and from here to middle 2.16, means 4 times. 4 times of this 2.16 will give you the wavelength. Okay, so same thing is done here, 4 into 2.16. Next question. A chlorophyll present in green leaves of plants absorb light at this frequency. Okay, calculate the wavelength of the radiation in nanometer. So what you have to calculate? You have to calculate the wavelength. Frequency is already given. So we know the formula C is equals to nu lambda, and we know that for every electromagnetic radiation, the speed of light is fixed, which is 3 to 10 to the power 8. So if you put value of speed, value of frequency, then you will get the wavelength. C is equals to nu lambda. We have used the same formula. Lambda is equals to C by nu. That gives you 649.4 nanometer. Next question. Next question says that what is the difference between the term orbit and orbital? So orbit stands for the shell in which the electron is moving. Orbital stands for like px, py, pz. This is the orbital. Okay, and one is subshell, which is P. So if we are simply calling it P, so it is P subshell. When we are saying which P, Px, Py, Pz, then that is our orbital. Okay, an orbit is something in which the electron is there. Okay, so this is the difference. If we talk about the orbit, so it is basically the energy or the probability. Okay, if we talk about the orbital, then it is the orientation, right? Next question. So we will move up to question 40 today, right? So this is these two questions are our last question. Table tennis has a mass of 10, speed of 90 meter per second. If speed can be measured with accuracy of 4%, what will be the uncertainties principle? So 4 by 100 is the what? Is the speed accuracy, right? So 4 by 100, that is 0.04. So we know delta V. So we know that lambda delta x into delta p is equals to h by 4 pi. Okay, so we know this. It is greater or equals to 4 h by 4 pi. So we will take the equal case. Okay. Now, since delta x, okay, if the we don't know where the v is coming here from, so what do? We simply put the formula for p. So p is equals to delta mv. So p is equals to mv. Now mass is certain, so therefore velocity is uncertain. So delta, so we can write that delta x into delta v is equals to h by 4 pi m. Mass I have just transferred it there. Delta x is already known, so delta v is already known. Delta x can be calculated from there. Okay, the same thing has been done, right? So 4% of 90, so 0.04 of 90 is 3.6. Okay, so we put all this thing here and we got 1.46 into 10 to the power minus 3 at the correct option. Next question. The effect of uncertainty is insignificant only for motion of microscopic particle. Justify with the help of experiment. So what we have done, we have taken a object which is having a mass of a milligram, a smaller substance, right? A small, very small substance. Now we calculated the uncertainty in say velocity, right? That comes out to be 0.52 into 10 to the power minus 28, which is very, very small. And due to this reason, we are not seeing the Heisenberg uncertainty principle applicable to this. Okay, although it is applicable, but it is not visible from our current analytical method that we have to calculate the velocity. Clear? So this was for today's lecture. With this, I end my lecture. Thank you.